Welcome to the third part of 6.1 concepts of oxidation and reduction. In this video, I would like to focus on writing half equation and combining to write a chemical equation. Balancing half equations of oxidation and reduction are quite difficult process to memorize, so yeah, please pay attention. Okay. So because we are dealing with redox reaction, oxidation and reduction always occur at the same time. One species will lose electron and one species will be gaining electron. Without the transfer of electron, it's not redox reaction. Now, in a redox reaction, there always are two half reactions, one for oxidation and one for reduction. These two half reactions can be combined to show a overall redox equation. Chemical equations can be written to represent the two half reactions and in the overall redox reaction. I already said that, didn't I? So copy that down, please. All right. In this example, I would like to use a galvanic cell, which you will learn more about in 6.3, because that's where electrochemical cells will be introduced, and you'll be building this. But anyway, if you use make a thing called galvanic cell with zinc and copper, redox pair can be written as, oh, that's a diagram by the way. So zinc is being oxidized there and losing electron to this way to copper side of the galvanic cell. When the electrons are moving, that causes the electric current and the light bulb can get turned on. And copper is the one that's gaining electrons. So how can we write two half equations from this? Well, redox pairs are usually expressed as expressed with a slash or a vertical bar usually, and in also square brackets. So zinc solid slash zinc 2 plus ion AQ close bracket. That shows that it's zinc reactant is now after the reaction it became zinc ion. Similarly, before the reaction, the Cu2 plus was the reactant, and as product it produced CuS, Cu solid, copper solid. The redox half reactions can be written as follows for these two. Just waiting a bit. Hang on. There you go. All right, so zinc arrow, zinc 2 plus 2 E minus. So you have to show the electrons and how many electrons have traveled to copper. So copper side is now gaining. So on the reactant side of the equation there, half equation there, have 2 electrons written. And as product, you are now seeing a CuS, Cu solid. So there will be more deposit of copper in it. Number of electrons in this case are balanced, as in zinc atoms are losing 2 electrons and copper is gaining 2 electrons each. So you can just cancel them out because 2 electrons on one side and 2 electrons on the other side. So you can just cancel them out. So if you combine these half equations there, you would see ZnS plus Cu2 plus, that becomes Zn2 plus Cu. Are we at that? Now, if the electrons weren't balanced, i.e. if you are using something else, some other element, say maybe lithium, lithium instead of zinc, that would be releasing 1 electron per atom of lithium. So you would have to multiply the whole thing before the whole oxidation reaction, half equation, by 2 before combining, so that you can balance the number of electrons involved. To balance the half equation, there is a process that you can use. Firstly, to balance the half equation, you need to balance key atom except for hydrogen and oxygen. So if you're using, say, manganese, or you would have to look at manganese, and you need to balance the number of the atoms involved on both sides, and balance the oxygen. That's the second step, with by adding water to the other side where lack of oxygen is lacking. Thirdly, balance hydrogen atom by adding H+, hydrogen ion, to the side that's missing some hydrogen. And finally, balance the charge by adding E minuses. So electrons need to be shown if the charges of reactant side and product side are not balanced. So do the balancing with electrons. Finally, write the states, define the states. There's a mnemonic for it, and I call this mnemonic Mr. Cohees. I don't know, Spanish speaking guy or something. K for key atoms, O for oxygen with water, H for hydrogen ions, E for electrons, S for states. Cohees, just cohees. Just remember that. Now, once you got the two half reactions, half equations, then you can combine. And here is how you do it. Balance the number of electrons in half equation by multiplying. Then combine two half equations, and after that, make sure you cancel like terms. For example, you might end up with I don't know, 6 hydrogen ion on this side and 10 hydrogen ion on this side. Then you can cancel out 6 from each side. Then you might have 4 hydrogen ions left on one side. So you can do that usually for water as well. Electrons must be cancelled out. The overall reaction should not contain any electrons shown. And in the next video, we'll look at this example.